Hello and welcome to this lesson about graphing on limited domains and ranges. The learning target for this video is knowing how to restrict the domain or range of a graph and how that's going to end up impacting what the graph actually looks like. So first, let's do a quick little recap on domain and range. So domain, we have to remember, essentially is your x values. And range is your y values. Oops, let's clean that up a little bit. There we go, y values. And so what we're going to essentially end up doing with our domain and range is we're just going to sort of be limiting how much of the x we're going to be drawing the graph on, or how much of the y we're going to be drawing the graph on. Now, most of this is going to be dealing with domain values, all right? And we'll be dealing with domain anytime we have y equals something of x, so mx plus b, or if we're dealing with ax plus by is equal to c. The only real time we're going to mess with range values is if we have the vertical line equation, which is x equals some number. Because if we think about what that looks like graphically, this is a vertical line. And so what we're going to do is snip off parts of it. And essentially that phrase right there, snip off, is a good way to think of what we're going to be doing. So let's write that down. Snip off. One way we can think about this is we're essentially cutting off pieces of the graph so that way it fits. Think about like anytime you've done some cutting in school, like, someone gives you a shape, you got to cut it out. You're following the line and you're cutting off all the extra. Same thing's happening here, except it's in an algebra class and we're doing it by restricting domain and range. But the instructions and the process is very, very similar. So let's talk about what this looks like. Let's look at a graph that's really simple. Y equals x. So y equals x has a slope of 1, so we plot some points. And we can just keep going. Down 1 over 1, down 1 over 1, up 1 over 1, and keep going like this right here. A little bit off, but it's all good. I think we get the point. Now, if we're going to talk about the domain, we will use these little squiggly lines, and then what we're going to do is put some inequalities of x. So for example, if I were to say x greater than or equal to 0, and then make that my restricted domain, the only x values I care about for this graph are from 0 going that way. And so this part of the graph is the one that I really care about, all right? Because I said x has to be greater than 0. Now, let's play around with it a little bit and move some things. So now let's get rid of the yellow. And instead of saying greater than 0, let's now say it has to be less than -2. Well, what I'm going to do is go to -2 on the x-axis, go down to my graph, and if I want to be less than, the graph can only be drawn from here. So that yellow line is the only part of the graph that I really care about. Now, let's switch things up a little bit, and let's talk about restricting the domain. So that process will also look very, very similar. So this time, let's say we have something like x equals 5. Well, if x equals 5, we would just be drawing a vertical line at 5 like that. When it comes to restricting the domain, or we're not going to restrict the domain because there really isn't much of a domain. The domain is all the x values and there's only one, 5. So we're going to restrict the range. And that process will be the same. So let's say we're going to go with y greater than or equal to 0. We're going to look at 0 on the y-axis, not the x-axis necessarily. And again, we want it to be greater than 0. We're going to go up. And since it says greater than or equal to, what that means is like this would be a closed circle. If it was just greater than 0, it would be an open circle at the very end. But that's how we can restrict the range, and so we can do is snip parts of the graph off. Now, let's make things just a little more complicated, but we'll use a simple graph to kind of explain it. Let's say, go back to y equals, and this time we'll go with a horizontal line of 3. So at 3, we draw a horizontal line right here. But now what we can do for the domain is maybe we could say it's going to be from -5 less than x less than or equal to positive 5. So again, I'm going to look down here, and this is where I want it to be. But now, according to my inequality, at negative 5, it'll have an open circle, and at positive 5, it'll have a closed circle. Now, this isn't the answer down here. The answer is still up there. I'm just going to essentially draw an open circle there, trace over the line, closed circle there, and then erase it. That would be the answer. What I've done is I've snipped off the parts that are not in the domain. So that leads to this conversation right here. We have two techniques for this. Technique number one is that snipping technique I just showed you. Technique number two is to only graph the appropriate area. So let's do a couple examples. Let's say, again, we'll just keep the graphs easy for the sake of demonstrating this. Y is equal to x minus 4. And here, for this domain, I want it to be from negative 2 less than or equal to x less than or equal to 4. All right, so let's do the first tactic. And I'll do that in yellow. So what I just do is I draw my graph as normal. All right, now if you're doing this on paper, you need to do this with a pencil, not a pen, because eventually you're going to have to erase it. So y equals x minus 4, I go here, I go up 1 over 1. If I keep following that, I should go to there, and then I draw my line. Keep going, follow the slope, keep going, follow the slope. Perfect. All right, now what I have to do is apply the domain, which is between negative 2 and 4. Well, that is from here to here. So I go to the graph, come on down here. I will draw a point because it is less than or equal to, and it's the same on the other side. So I don't have open circles. I trace over that spot, and then I take my eraser and I erase everything else. And so the red line is my answer. Okay? Again, the other strategy would just be to look at this right here and start at, what is it, 4? Oh, it should be a little bit lower, right down there. All right, start at 4 and then go down 1 over 1, down 1 over 1. All right, I've hit my domain point, up 1 over 1, keep going, and just really kind of focus in on that window. However, I think the snipping tactic would be the best. All right, one more example. And we'll call it good. Okay, let's say I want to graph x equals negative 2, but I'm going to restrict the range because it's a vertical line, and I would just want, let's go from 3 less than or equal to y, which is less than or equal to 5. Again, I'm going to use this snipping tactic. So x equals negative 2, vertical line right there. Draw it all out. Now, oops. We're going to put that there. I'm going to apply my new range. So I'm going from from 3 to 5. So it's a real short one, right here to right there. Connect it. That's it, because this was the part of the range that I was restricted upon. An analogy I like to make is sort of like if you pretend to make like binoculars with your hands, where you kind of make a circle and you look through it. Imagine doing that for one eye and closing the other eye, so that way you're kind of really limited in what you can see. That's what we're doing. We can only see this part of the graph. The rest doesn't matter. It gets erased. And so that little part right there, that's the answer. So we're just graphing, but we're not maybe drawing the whole picture. We're limiting it. We're cutting off the things we don't want. And so hopefully this makes sense. We'll talk more about it. We'll do some projects with it. But this is a nice little introduction to how we're going to restrict our domain or range.